Okay, this is the number 5 problem on the 4-3 review. Calculators are not allowed. And if you'll notice, I've kind of folded up part C of this because I personally find this problem much easier to work with if I can draw the picture first. I'm more visual, so I like to look at the picture to see where my maxes and mins and all that stuff are. So part C is we want to sketch the graph of the function, and we can use what we know about outputs to get points. We can use what we know about slope to determine whether we are increasing or decreasing, and we can use what we know about the second derivative to determine whether we are smiling or frowning. So the first thing I'm going to do is I'm going to label all of the points and plot them. So I've got the point 0, 0, I've got the point 1, 3, and I've got the point 2, 2. Then I'm going to use the information I have about what's going on between those points to graph the connections. So here, this f of x being positive tells me that I have to stay above the x-axis when I'm graphing. The first derivative being positive means I need to be increasing or getting larger. The second derivative being positive means I need to be smiling. So to get from the point 0, 0 to 1, 3, I need to stay above the x-axis, I need to rise, and I need to smile. So we can see that getting from 1, 0, 0 to 1, 3 will look like this. Okay, between 1, 3 and 2, 2, so between these 2 points, I'm going to still be above the x-axis, I'm going to be falling, and I'm going to be smiling. So in order to get from this point to this point with those 3 criteria, my picture will look like this. Notice I'm smiling as I'm falling. Now to verify what's going on at 1, 3, see that f prime does not exist because we have a corner. And if the first derivative doesn't exist, then we can't have a second derivative. That hopefully makes sense without too much more clarification. Okay, in between 1 and 2, so, we already did that. So now between 2, 2 and the end, well, we don't have the end location, but we do know that we've got to get all the way to 3. So what this tells us is we need to stay above the x-axis until 3. At 3, we don't know, so we can either be above or we could actually touch. But we could not be below the x-axis at 3 because then right before 3 we would not have a positive output. So that means when we connect our point that goes with 3, we just have to close the point. We can't have an open point, and it needs to either be at the axis or above. So I'm going to stay above just to stay out of trouble with any possible crossing, inadvertent crossing. So in between this point 2, 2 that we know and the 3 comma whatever is positive or 0, we know that we have to be above the x-axis, we have to be falling, and we have to be frowning. So I'm going to put a point right here, and I'm going to fall and frown. So now we've got the right side of the graph. We were told that we're supposed to have a picture from -3 all the way to +3, and currently we only are going from 0 to 3. So if we look at the information that's given to us, we were told that f was odd. So being a smart test taker, you might also predict what could happen on the exam. Odd is a good candidate, and so is even. So you need to know how to go from one side of the graph to the other if you know odd or even. Odd functions mean that we are symmetric around the origin, so that means we would draw this picture reflected over the x, or excuse me, over the y and then over the x. So we'll get the point -1, -3, and we'll get the point -2, -2, and we will have this same picture reflected. So our function now looks like this. So if we look at this picture now, it's going to be much easier to write down all the information that we have to write on the original problem. So part B says we want to find the x-coordinate of each point at which f attains an absolute max or an absolute min, and we want to know what the x-coordinates are, or excuse me, whether we get a max or a min at each one. So looking at the picture, we can see that we have a local max here, we've got a local min, we've got a local max, and a local min. So how do we figure out what our candidates are? because if you look at the rubric, I'm going to grade you on listing the candidates. So we know that candidates are always going to be endpoints and critical points. So we're going to write down candidates are endpoints and critical points. And then we're going to list them. So my candidates are going to be 0 because the derivative is 0. It's going to be 1 because the derivative is undefined. It's going to be 2 because the derivative is 0. And it's going to be 3 because that's an endpoint. Because it's odd, I'm going to get all those same values, only they're opposites. So if we have evidence that we are considering those values as possible criteria for absolute maxes and mins, then we would get our first point for considering the candidates. Now, looking at the picture, we can see that our highest value occurs at 1 and our lowest value occurs at -1. So we can say the absolute max occurs at x equals +1, and the absolute min occurs at x equals -1. Part B says I now want to find the x-coordinate of each point of inflection and justify the answer. So in order to be a point of inflection, we must have 3 things. The first thing is that f prime of A must exist. If you don't have a first derivative, you can't get an inflection point. The second thing that must happen is f prime of A must be 0 or undefined. The third thing that happens is that f double prime of A must change sign. Actually, we would say f double prime of x changes sign at x equals A. So if you have these 3 conditions, then you'll have a point of inflection at x equals A. So we're looking for f prime existing, f double prime being 0 or undefined, and f double prime changing sign. So we'll look at it on the table first, and then we'll look at it on the graph, and we'll see that we get the same information either way. Okay, so on the table, f prime existing means f prime can't be here. So that means 1 is not a candidate for an inflection point. F double prime being 0 or undefined would say we can use 0 or 1 or 2, but because we didn't have the first derivative defined here, that's not in the running. So really we're looking at 0 as being a possible one or 2 being a possible one. If we look at 2, we can see that our second derivative changed from positive to negative. So 2 will be an inflection point. Because of the odd nature of our graph, we're also going to get an inflection point at -2. So then the next thing we have to do is double check what's going on at 0. It's a little hard to see from the table because it's odd, and predicting table-wise what's going to be happening on the other side is a little harder. So let's go back and look at the graph, and we can see here at 2 I changed from a smile to a frown, and I had a nice tangent there. So that means 2 is going, or yes, 2 is going to be an inflection point. Same argument over here. We changed from a smile to a frown, and we had a nice tangent. So -2 is going to be an inflection point as well. Now the last one that we can see on the graph that's a little harder to see with the picture is at 0 we have an inflection point as well, because at 0 my first derivative flattened out, it was 0, and then my second derivative changed from a frown to a smile. So that meant I had a negative second derivative and a positive second derivative. So that means 0 will also be a point of inflection. So over here, we also have x equals 0. Now it asked for the x-coordinate of each point, so we can just give the x-coordinates. Some of you might also have chosen to give me the actual points. So at 2 I get a 2 out, at -2 I get a -2, and at 0 I get a 0. So these are my 3 points of inflection, and my justification is the listing of the 3 criteria required.